a little bit of a doozy. All right, so x cubed plus 1 over x squared minus 4. And notice there's also this negative sign. Don't want to forget about that negative sign. So negative x cubed plus 1 divided by x squared minus 4. So first thing, we want to break this into factors because that's normally our first step. So how can we factor the top? Well, x cubed plus 1. How can we break that down? Well, we notice that we can definitely, if we plug in negative 1, that's going to turn to 0. So we know that x plus 1 has to be a factor. X plus 1. Now there's going to be some amount of x squared, some amount of x, some amount of constant. So constant, some x squared. We've got x cubed, so it must be that there's only one x squared. We've got 1 at the end, so it must be a constant of 1 at the end as well, right? X times x squared is the only x cubes we'll get, so we want only 1 x cubed. 1 times 1 is the constant we'll get, so we want to make sure they're both 1. So now we need something in the middle that will cause the x squareds and the x to cancel out. So if we've got x squared here, then we need to have it be negative 1 here, so that when x times x here, it will come out as negative x squared because we've got positive 1 x squared. So those two cancel out. So we see that x cubed plus 1 is the same thing as x plus 1 times x squared minus x plus 1. So that's the same thing on our top. How can we factor our bottom for our thing? So for our rational function, that's going to break into x minus 2 times x plus 2. Remember, we had a negative sign out front in the beginning, so we've got a negative here still. So f of x equals negative x plus 1 times x squared minus x plus 1 over x minus 2 times x plus 2. Great, that's helpful. But there's something else we have to do. If we want to get to what the horizontal asymptote or slant asymptote is, let's figure out which one it is. Cubed here, squared here. So our numerator is 1 degree higher than our denominator, means we've got a slant asymptote. How do we figure out slant asymptote? Through polynomial division. So we want to do polynomial division on this. So x squared minus 4 divides into, now here's where things get a little bit tricky. We've got this negative here once again. So we can't divide into x cubed plus 1 because then we'd have to remember to deal with that negative. So we can make things a little bit easier on ourselves, and we can distribute that negative and we'll get negative x cubed minus 1, because that's the same thing as what was initially there, divided by x squared minus 4. So now we can be safe by doing that instead. X squared minus 4, so negative x cubed. How many x squareds do we have? 0 x squareds. How many x's? 0 x's minus 1. X squared minus 4, how many times does x squared go into negative x cubed? It's going to go in negative x times x squared, negative x cubed, negative x times negative 4 becomes positive 4x. We subtract this whole thing, distribute the subtraction. Negative x cubed plus x cubed becomes 0. 0x minus 4x becomes negative 4x. We bring things down. We got 0x squared minus 1. So we've got a remainder of negative 4x minus 1. And what came out was negative x. So what we've got is that f of x is also equal to, can be written in the form negative x plus its remainder of negative 4x minus 1 divided by x squared minus 4. Great, so now we've been able to figure out what the slant asymptote is. The slant asymptote is this negative x right here. Now, we might want to check this, because it's easy to make a mistake with polynomial division it's just easy to make a mistake with polynomial division. So let's check it. Let's make sure that this f is the same as the f that we started with. So we can put this over common denominator, negative x times x squared minus 4 over x squared minus 4 plus negative 4x minus 1 over x squared minus 4. We distribute up here. We've got negative x cubed minus 4x. Let's combine our two since they are over a common denominator. X squared minus 4 plus negative 4x minus 1. So the negative 4x cancels with that was my mistake. Negative x times negative 4 becomes positive 4x. So it does cancel out. Positive 4x and minus 4x, they cancel out. And we get negative x cubed minus 1 over x squared minus 4, which, as we already talked about, is the same thing as negative x cubed plus 1. We can distribute that negative and we get negative x cubed minus 1. So checks out. That's good. Great. So let's see both of our two ways of looking at this. There's the factored form. that we figured, and then there's also the polynomial division form. So the polynomial division form is necessary because it gives us our slant asymptote, and the factored form is necessary because it tells us our vertical asymptotes and also helps us figure out some other things. Hoi. And then also we just initially started with, just so we can still have it on our paper, so to speak, x cubed plus 1 negative x cubed plus 1 over x squared minus 4. That might be helpful since it's not that many numbers. It might be helpful for when we actually have to calculate some extra points. Okay, so what's allowed in our domain? Our domain forbids when x plus 2 or x minus 2 becomes 0. So that's going to happen at negative 2 and positive 2. So x is not allowed to be negative 2. It's not allowed to be positive 2. Where are our vertical asymptotes? Our vertical asymptotes, notice that there's no common factors between the top and the bottom, right? We've got x plus 1 and x squared minus x plus 1 on the top, and x plus 2 and x minus 2. None of these things have anything in common. They're not the same factor exactly, so we can't cancel anything out. So we've got vertical asymptotes at where we're forbidden for our domain, negative 2 and positive 2. What about horizontal asymptotes? We figured out it wasn't a horizontal asymptote. We figured out it is a slant asymptote because the degree was one higher on the top, so we'll write it as slant asymptote. But the idea in either case is the same thing. What happens in the long term to this function? That's going to be y equals negative x, right? The part that in the long term, this part on the right that I just circled, it goes to 0, right? With very large x's, that thing will eventually get crushed down to 0. So we're left with just this thing in the box, the negative x, and that's why it's our slant asymptote. And we might want to know the intercepts just because they're not too hard to grab. So we'll have intercepts. Intercept, we plug in 0. 0 plugs in negative 0 plus 1 over 0 minus 4. So negative 1 over negative 4 becomes positive 1/4. Let's plug in some other ones. Negative 1 and 0. Sorry, we can figure that one out because if we plug in a negative 1 here, the whole top goes to 0. So that's our an x-axis intercept. So let's draw this thing in. It's going to be a beast to work with. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm going to mark in a location of 5, 3, 4, 5, just so we have a little bit of 1, 2, 3, 4, 5, a little reference that we can easily find our way around. 1, 2, 3, 4, 1, 2, 3, 4, 5, negative 5, 1, 2, 3, 4, 5, negative 5. Great. So we have a little bit of reference there on our thing. Now, let's draw in our vertical asymptotes. Vertical asymptotes at negative 2. And positive 2. And we have a slant asymptote at y equals negative x. So what does that look like? Goes at a 45-degree angle, right? It's got a slope of negative 1. So for every step to the right it takes a step down. So it cuts through nice and, whoops, that was not quite as nice and even as it wants to be. Okay. So we see a slant asymptote like that cutting through the whole thing. All right. So we can plot our intercepts. 0 is at 1/4, so just above. And negative 1 is at 0. Now at this point we see, oh man, we need a lot more information, right? We need to plot a lot of points. So I've brought a bunch of points. I figured them out beforehand with a calculator. We don't have enough room to calculate it all by hand, and honestly it'd be kind of boring. But occasionally you will have to run through this yourself. So just be aware that when you need more points, you just work them through it, right? We've got negative x cubed plus 1 over x squared minus 4. We can just plot in points and figure them out. So let's look at what happens as we get close to this vertical asymptote of negative 2. So we plug in negative 1.5, and we find out that we are at negative 1.35. So we can plot that point, negative 1.5. We're at negative 1.35. Okay. And I'm just going to put down a whole bunch of points and then we'll plot them all at once. 1, we're at 0.66, so 6 is repeating, so if 6s are repeating, it's just 2/3. What about -3? We're at 5.2. At -4, we're also at 5.2. That's interesting. -5, we're at 5.9. At +3, we're at -5.6. At +4, we are at -5.42. At +5, we are at -6. Okay, that should be about enough for us to figure things out. So at +1, we're at 0.66666, or we are at 2/3 more accurately. We also might want to know where we are at 1.5. Didn't do that one. Whoops. But 1.5, we could figure that out. 1.5 cubed plus 1, 3/2 cubed. That's a little difficult. It's going to be, we know it is going to wind up going up here though, because if we think about a number that is just a little under 2, then just a little bit under 2 is going to cause this bottom part to be negative, and it's going to cause the top part to remain positive, so negative in front. Remember, we can't forget about this negative in front. So negative in front, positive on top, negative on the bottom, cancels out when we get positive, so we're going up this way on this side. And when we are at negative 1.999 just to the right of our vertical asymptote on the left, we know that we're going to be going down because we see at -1.5 we're going down already. If we consider -1.99999, x squared minus 4, that's once again going to be negative because it's smaller. X cubed plus 1, -1.99999, that's going to make a number that is negative on the top because it'll be negative. Negative cubed is larger than the +1. -1 point anything cubed is going to be larger than +1, so that'll be a negative. So we've got a negative on the top, negative on the bottom, negative in front, comes out to 1 negative left, so we're down here. What about a little bit to the left? If we were at 2.0001, then the x squared minus 4 will wind up being a positive because it will be just large enough to beat out that -4. X cubed plus 1, still going to be negative, but we've got that negative in front, so it cancels, so we'll be going up on this side. And over here at +2, a little bit over 2, x squared minus 4, if we're at 2.0001, that squared minus 4 is going to be larger than the -4, so it will be positive. X cubed plus 1, remain positive, but we've got that negative in front, so it'll be going down here. So now we know the directions of all our asymptotes. Let's plot in the rest of our points, and we'll be ready to draw this sucker in. 1, 2, 3, 5.2, so 5, and just a hair up. -4 is going to be at 5.2. -4 is going to also be at 5.2. My graph is a little bit high on the y equals x. My graph is not quite perfect, sorry. -5 will be at 5.9. And if we go this way, we're going to go up here. So one thing to notice is that we're actually going, we wind up being, there's something odd going on between -3 and -4. If we were to calculate another point, we might want to try like -3.5 or -3.2 to get a sense of where it's lower. We would eventually notice that it actually dips down, hits at absolute lowest minimum around here. We could figure that out precisely if we had a calculator and a lot of time. 3, we plug in 3, we're at -5.6, so a little below. Here we are. At 4, we're at -5.42. Once again, there's that interesting thing where it will curve back up. Turns out that the minimum is somewhere between those two. At +5, we're at -6. Once again, my graph of the green slant asymptote isn't quite perfect. Probably really my red axes aren't quite exactly the same scale. The problem with drawing it all by hand without having a ruler. But at this point, we're finally ready to graph this thing. So we're going to get on this side of the slant asymptote, this side of the slant asymptote. So in the middle part where we don't have to worry about the slant asymptote because it's too close to these verticals, we're going to be like this. When we have the slant asymptotes, we'll be pulled off this way, and then we get pulled along the slant asymptote here. And we'll get closer and closer over time. Pulled along the vertical asymptote, then it goes dips, and then it gets pulled along the slant asymptote. Wouldn't curve away there, that's just my imperfections. There we go. And then it gets closer and closer to that slant asymptote the whole time. It's pretty tough to draw something this complex, but this is absolutely as complex as you're going to wind up seeing in a class or have any homework or tests have to do. So at the worst case, you just wind up having to take a lot of points, plot a bunch of points, and you can figure out how this thing behaves. You can figure out where the asymptotes are, you can figure out the slant asymptote, horizontal asymptote, vertical asymptote, all that business, your domain. You can figure out all these things, and when it comes time to graph, you just have to punch out a lot of numbers so that you can actually see what the picture looks like. But all in all, it's not that hard if you just make enough numbers. All right, hope everything there made sense, and we'll see you at Educator.com later. Bye!